All right, ladies and gentlemen and programmers, lesson 3, part 3, we're going to learn about threaded coding. All right, so this is what we have so far for our crab. So if you look at the crab's act method, it's going like this. Now, we added this, and then most recently we added this section, and our act method is getting longer and longer and longer and longer. So, but we're going to continue to keep adding functionality to the crab. We're going to keep making the crab do more and more things. So what's going to happen to our act method if we keep adding functionality to the crab? Okay, well, the answer is, I'm not going to tell you. You tell me. No, I'll tell you. The answer, well, no, you answer it. Forget it. I'm not telling you. You guys figure it out. All right, let's take a look at this. It said here's an act method, right, that we have. How about this? Turn at edge, random turn, move, look for worm. Which one's easier to understand what's happening? This one or this one? Well, the answer is this one. This one's a lot easier to understand what's happening. This one gets a little bit cluttered. So back up to this. What's going to happen if we just keep doing that, adding more and more stuff to the act method? It's going to get impossible to understand. It's going to get unwieldy. It's going to get crummy. All right, so we're going to stop writing code like this, and we're going to start using code like this. This is called threaded coding. Okay, well, we'll talk more about it in a second. All right. Look at that. It's a sissy blue color. What does that mean? It means whoosh, whip out your handout. We got some notes to take. All right, threaded code. We can improve this by, if we continue to add code in this way to our act method, it will become longer and longer and longer and longer and eventually really hard to understand. We can improve this by chopping it up into smaller pieces. This makes the act method easier to understand. It's called threaded coding. So from now on, I'm going to teach you how to do threaded coding, and I expect you to use threaded coding. Okay, so let me teach you how. Okay, so here's what we're going to do. Write the method call look for worm in the act method of the crab. Does it work? Okay, so this, I usually don't like really teaching you stuff, you know. I mean, I'm supposed to be a teacher, but I just don't really like teaching you stuff. But on this instance, I'm going to have to. Okay, so what does it mean by write a method called look for worm in the act method? Well, it means you're going to come over here to the act method, and I'm going to make this bigger. And you're going to come down here. We'll have to be inside the act method. Remember, you have to respect the braces. Okay, so we're going to click right here inside of there, and we're going to say look for worm. Now remember, we're doing it camel case, so like the camel, his little head is lowercase because he's getting a little drink of water. Right? Wait, where's his little camel head? His little camel head is lower because he's getting water, but then he's got a hump and then a hump over here. So that's called camel case. So always start our methods with a lowercase. So we're going to say look for worm, and then we're going to semicolon. Okay, so we're going to ask him look for worm, and let's see what happens. And it says, what does this say? It says cannot find the symbol method look for worm. So we asked him to look for worm. He doesn't know how to. Okay, but we followed the instructions. That's what they just asked us to do. Or that's really, it's what I asked you to do. Okay, does it work? What error message do you get? Why can't the crab look for the worm? Answer that question. You can figure that one out. Okay. Okay, so so basically the deal is if we're gonna ask him to look for worm, we have to teach him how to look for worm. So we're gonna create a new method. Let's move this. Okay, so we're gonna move this inside of a method called look for worm. Okay, so what we're going to do is I'll show you how to just follow me. Okay, so look, this doesn't work. So what we're going to have to do is here's the beginning and the end of the act method. Here's the end of the class. So I have to go in here somewhere. So I'm going to click here, I'm going to hit enter, and I'm going to create a method definition. So I'm going to say public void because it's a command, and I'm going to call it look for worm. Okay, parentheses, parentheses, and then I'm going to hit enter. I'm going to have my opening curly brace, enter, enter, closing curly brace. Okay, now check this out. Oh, look at this. No syntax errors. Okay, so now all of a sudden, this is good code now. It works. Well, why? Well, because I asked him to look for worm, and now I have actually taught him how to look for worm. Well, at least I pretended to, but I really didn't teach him very much because there's nothing in the body of this method. Okay, so well, what's the code? Where in the world would I find code how to look for a worm? Well, it's right here. It's in the act method. So I'm going to take this, I'm going to copy it, I'm going to go Control X, I'm going to come right here, I'm going to go Control V. Okay, so now still the code's still good, and now will this work? So if I just say, let's backspace this a little bit. What am I doing here? Let me delete this. Okay, and then I'm going to go Control Shift and I to auto layout it. Control Shift and I will make an auto layout. Okay, or you can go Edit Auto Layout too. All right, so now let's see if this works. If I ask him in the act method to look for worms, will he do this? Well, let's find out. Let's go to our little handy dandy project here. Okay, so I'm going to put in a couple crabs. I'm going to put in a couple worms. So if I hit run, all right, so now he goes around and he eats worms. Okay, now, is that any different than it was before? Nope, it's exactly the same as it was before. Well, why in the Sam Hill did we do it? Well, let's make sure I got everything here. Okay, so oh, you know what we forgot to do? Hold on, go back. Okay, so one thing I forgot to do is whenever you have to click inside here and go edit, add method comment. Okay, so you always have, whenever you create a new method, you always want a method comment. So we'll put some instructions here. If you see a worm, eat that worm. Okay. Okay, so at any rate, always do a method comment from now on. So it doesn't do anything. It doesn't do anything, but it tells you what this thing does. And it also, the other thing I like about it is it makes you visually understand, oh, here is a new method definition. I'm teaching him how to do something he didn't know how to do before. Okay. Okay, so this is a way of making our act method shorter and less complicated. So we're moving it from the act method into its own method definition. Okay, creating new methods. Okay, so we already did that. Okay, quiz question. Does using threaded code make our crab do anything different? And why did we do it? Okay, answer those questions. Oh, get out your handout. We've got some new stuff coming. All right, let's jump back though. Does threaded code make our crab do anything different? No, it does this exact same thing. Why did we do it? We did it to make our act method more simple. We want to make our act method look like this. So a series of method calls, and then the method definitions are farther down. So it makes it way easier to read than this. So we got rid of this whole thing and replaced it with that thing right there. Okay, so write this down. A method definition teaches a crab to do something he didn't already know how to do. The act method is not immediately executed, but the method can be called. The action is the oh, did I say act method? The action is not immediately executed, but the method can be called with a method called later to execute it. What does that mean? It means when I write down look for worm, it's never going to happen unless I ask it to right here. So I'm teaching it how to, but then I ask it to later. Write this down in your notes. Let me show you what I'm talking about. Okay, so if I go into my crab and we'll go like this. We'll make this into a comment. Okay, so that code never runs. Okay, well, what happens? Well, try it, but basically what's going to happen is the crab won't eat the worms, right? Because I taught him how to, but if I need to ask him to, I'm going to have to ask him to in the act method. The act method runs automatically, so everything in here runs automatically. This method, oh, I'm pointing with my finger, you can't see it. So this method's never going to run unless I call it from the act method, okay? So if I go like this, all of a sudden, this is going to work again. It's going to eat worms again. All right, let's keep going. Okay, the next thing is comments. Oh, this is also a handout. Grab your handout. Comments are written into the source code as an explanation for human readers. They are ignored by the computer. So all this stuff right here. So this would be a better comment. At any rate, so your comments are going to be like this. This is for human readers to explain this method. Okay, these are comments. From now on, we're going to write lots of comments, and always when we have a method, we're going to put a method comment. All right, grab out. Oh my goodness, we are on a handout rampage here. Get out this handout and write this down. The discipline of object-oriented programming is based on methods that are attached to objects or classes. So basically, we have a crab, and we're writing all kinds of methods for him, and then we're going to ask him to do them. okay, that are attached to objects or object classes. So for example, move is attached to a superclass that's attached to animal, but look for worm is written right here in crab. Check key press. Well, we haven't done check key press yet, but we're going to write that right in crab. In threaded coding, the executable program, the ACT method is basically a sequence of subroutine calls. Oh my gosh, we need to, yeah, so circle this on the notes because I should have made you write this, but this is very important. So circle this. So threaded code equals a sequence of method calls in the ACT method. Oh, I did make you write it. Okay, so your ACT method is going to start to look like this. Check key press, so we can like have keyboard control. Move, look for the worm. That's what our ACT method is going to start to look like. All right, I want you to create another new method named random turn. Select the code that does the random turning and move it from the ACT method to the random turn method. Then call this new random turn method from the ACT method. Make sure to write a comment for this method. Now do it again for turn at edge. So we're going to make random turn and turn at edge method calls in the ACT method, and we're going to write separate methods for them down below, just like we just did. Create yet another new method named turn at edge. Select the code that checks whether we are at the edge of the world and move it from the ACT method to the turn at edge method. All right, do that. Okay, so your ACT method should look like this. Turn at edge, random turn, move, look for worm. Okay, so that's what your ACT method should look like. Okay, so I'm not going to help you. I want you to try to do this on your own, and I don't really want to help you do it. So see if you can do it. I'm going to give you a bunch of help. Okay, all right, then answer these quiz questions. Make sure you can answer them. If you can't answer them, let me know. Okay. Great. All right, so let's do, maybe I will help you with this. I don't know. Let's go. All right, so let's see here. Let's jump over here. So if you figured it out, great. You can end this video now. If you need some more help, I'm gonna continue helping kids. Okay, so what we're gonna do is we're gonna go to the crab, and so we'll just do it one at a time. So we're gonna figure out a new name for this. So our new name for this is gonna be turn at edge. Okay. Semicolon. And again, doesn't know how to turn at edge. So what we're going to do is we're going to come down here. Here's the beginning of the look for worm, end of look for worm. We're going to hit enter. So we're going to say public void turn at edge, parentheses, enter, opening bracket, closing bracket. Okay, so now, all of a sudden it's happy, but we haven't done threaded coding yet, so we're going to go to Control X, come down here, paste it right here. Okay, so now we have a working turn at edge method, except for we need our method comment, so we're going to go edit, add method comment, method turn at edge. Okay, so there's our method comment. All right, so our ACT method is getting simpler. I'm going to delete these couple of lines. Can I delete these lines? Back. Okay, now what are we going to do for if greenfoot die? What does this do? Okay, this is turning random. So I'm going to click right here. I'm going to say turn random, parentheses, semicolon. So I've got another method call. It's not going to work. So again, I'm going to come down here. I'm going to hit enter. I'm going to say public void random. Okay, so not a semicolon, that kills it. So then opening, closing, curly braces come up here, and we're going to cut this. Control X, come down here, paste it inside our brackets there, and then we're going to go edit, add method comment, and turn random So, okay, and so now we have done it. Okay, so now our ACT method is very easy to understand. Turn at the edge of the world, turn random, move, look for worms. Now, let's see if he still functions. Let's see what he does. So we're gonna put in a couple crabs. We're going to put in a couple worms. And works exactly the same. Okay, so it doesn't do anything different, but now we have threaded code. Our ACT method is way easier to understand. Okay, so let's keep looking here. Oh, that's it. Okay, so that's it for this video. Hopefully that was helpful. I will see you next.